is called rational expressions and functions. What we're going to be focusing on today is multiplying and dividing. So first thing let's do is let's talk about what a rational expression is. So rational expression means a quotient of two polynomials. So an example of a rational expression is it's just a fraction. It would be like if you had 1 over 2. Rational just means you could write it as a fraction. Similarly, if you had like x plus 1 over x minus 3, or if you had x squared minus x minus 2 over x squared plus x minus 6. Those are all examples of rational expressions because they are expressions written as a fraction. First thing I wanted to do in this lesson, besides give you examples of rational expressions, is talk about the domain of a rational the domain of a rational function includes all numbers except those that make the denominator equal to 0. Let me show you some examples. Directions would just be to find the domain. Say we have a problem where it says f of x is equal to 10 over x. You could pick any number that you want to use for the domain, except whatever number makes the denominator 0. So in this case, 0 would make the denominator 0, right? So we would say for the domain, it might be helpful if you drew a number line and showed any number on the number line, except can't use 0. Because that would make the denominator 0. So the question is, how do you write this as a domain? We could pick any number to the left of 0 up until 0, and then we could pick any number from 0 on for forever. So the way that you would write this domain is you would say from negative infinity to 0 in union with 0 to positive infinity. This is called interval notation. We talked about that a little bit earlier on in the course. What about if we had x is equal to 3 plus 2x over 5? Would the denominator ever be 0? No, right? Because it's 5. So for this problem, we would say that the domain would just be all real numbers. There's no way that we can make 5 into 0. So your domain would be the entire number line. And the way you would just say this is from negative infinity to positive infinity. That would mean you could pick any x value. None of them are going to make the denominator 0. Try one more. What if we had f of x is equal to x plus 6 divided by x squared minus x minus 6? We don't want the denominator can't equal 0. So we have to try to figure out by factoring what are numbers that make x squared minus x minus 6 equal to 0, and then omit those from the domain. So you had a problem like this on your midterm. It wasn't in the form of a fraction, but we had to use the 0 product property in order to solve it. So this requires that we remember how to factor. So if you remember, what we did is we multiplied the first times the last number together, is negative 6. Numbers that multiply to be negative 6 and add up to be negative 1 would be negative 3 and 2. And then in order to factor this, you would write, instead of x squared minus x minus 6 is 0, you would say x squared minus 3x plus 2x plus minus 6 is 0. What we're doing is we're breaking up this negative x to be negative 3x and 2x. And then from here, we just cut it down the middle, take out an x, we write x minus 3, take out a 2, x minus 3, and we would write x minus 3 times x plus 2 is equal to 0. Finishing this, we just set the factors equal to 0. So x minus 3 is 0, so x is 3. Plus 2 is 0, so x is negative 2. One more of these to practice. What about if I gave you the problem f of x is equal to x minus 2 over 2x squared minus x minus 3? And actually, before you write that down, I got a little excited and I didn't finish the last problem. So we want to figure out x values that make it 0. we got 3 and -2. So on a number line, what this means is we could pick any number we want except what x is equal to. So you can't pick 3 and you can't pick -2. So we just have to figure out how do you write that in interval notation. Well, you would say from -∞ to -2 in union with -2 to +3. Once you figure out what x is equal to, we want to draw the number line and omit those from the domain. Let's do the same thing with this last problem, and then we'll move on to a different topic. Remember, when we're finding the domain, we just can't let the denominator be 0. So if the denominator can't be 0, that means that 2x squared minus x minus 3 can't be 0. Just like we did before, we want to factor this, solve it for x, and then draw the number line to figure out where the domain is. The way that we factor is we do 2 times -3 is -6. We want to look for numbers that multiply to be -6 and add up to -1, which would be -3 and +2. To give us 2x squared minus x minus 3 is 0. Writing the numbers that we just came up with, we're going to use -3x and +2x. Cutting it down the middle, we can take out an x and we get 2x minus 3. Taking out a 1, we get 2x minus 3. So factored would be 2x minus 3 times x plus 1. We set those equal to 0. We get x is 3/2 and x is -1. Just to finish this up, we draw the number line with -1 and 3/2 on it. And we say that we could pick any number for the domain we want except -1 and 3/2. This would be the domain. Whenever you're combining 2 different regions, we use that union symbol. Just give me a second to get caught up, and then we'll do the next one. So that's what I wanted to talk about with domain. Make sure we practice problems like that. And I wanted to talk about this next topic, which is simplifying rational expressions. So there's a few things we have to consider for this. One thing we want to make sure of is that we factor completely. When we talk about factor, just to jog your memory, we talked about GCF factoring. We also talked about grouping, trinomials, and special cases. That's the first thing we want to do is factor completely. Something else that we could do is we want to factor out a -1 to rearrange subtraction. And I'll show you some examples with that when we get there. For right now, let's just write it down so our notes are complete. And then the last step for these is we want to cancel common factors in the numerator and the denominator. So now that that's said, let's go ahead and take a look at these. And I'll show you what these examples look like. They'll ask you to write in lowest terms. All this means is that we cancel out common factors. So first problem looks like this. Say we had y squared plus 2y minus 3 divided by y squared minus 3y plus 2. What I said is we want to cancel out common factors. So you can't do this because those aren't factors. A factor is just something that you multiply times something else. So you can't just cancel out things if they're addition or subtraction. So what we have to do, first step we want to do is we want to factor this completely. So what we're going to do is we'll factor y squared plus 2y plus minus 3. And then we also want to factor y squared minus 3y plus 2. After those, just like we've learned how to do. This is the same thing. We want to find two numbers that multiply to be -3, add up to be 2. 3 and -1. And if we factored this would just factor to be y squared plus 3y minus 1y minus 3, cutting it down the middle. Give us y plus 3 times y minus 1. That's going to be the top. Y plus 3 times y minus 1. And then we'll just factor the bottom now, same exact way. 1 times 2 is 2. Numbers that multiply to be 2 and add up to -3 are -2 and -1. So similar to what we just did, we'll factor this y squared minus 2y minus 1y plus 2. If we cut it down the middle, out of -1, y minus 2 times y minus 1. That's completely factored. So now that we factored completely, do you see any common factors that we could cancel out? Yeah, so we'll just cancel those out, and we'll just wind up with y plus 3 over y minus 2. That would be the answer. That's in lowest terms. All right, let's try another one. Y plus 2 over y squared minus 4. What we want to do is factor, and it looks like the top doesn't factor, so we're still going to leave the top y plus 2. But that bottom does factor. If you remember when we talked about special cases, we talked about 3 different scenarios. We said one was if you have 2 squares that are being subtracted. This would just be a plus b times a minus b. Another one would be if you have 2 cubics that are being added together. Formula was a same sign b times a squared opposite sign, always positive b squared. And then if this was a minus sign between them, it would be a same sign b, a squared opposite sign, always positive. For this one, this is the same thing as just y to the second minus 2 to the second. So we factor to be y plus 2 times y minus 2. Do you see any factors that are the same? Y plus 2 is the same. So what do we wind up getting on top? If we cancel out that top, is it 0 or 1? 1. This would be the final answer. It's similar to if you had like 2 8s, you would cancel out this 2, and that would be 1/4. The top doesn't just turn into 0, it turns into 1. All right, I have 2 more of these. What if we had y plus 2 over y squared plus 4? Y plus 2 doesn't factor. Is there a special case for y squared plus 4? Yeah, that's not one of the special cases, right? So that's not one of those 3. So this doesn't factor. Which means it also doesn't simplify. try another special case. What if we had 1 plus e to the third divided by 1 plus p? Take one out of what? So it's suggested in class that we take one of these out with one of these, right? I understand what you're saying, so let me just elaborate a little bit more. What we can do is we could write the top as something cubed plus something cubed. We do have a formula for that. We have this formula right here. We could write the top as 1 plus p times 1 squared opposite sign, always positive, over 1 plus p. That's what we could do. We couldn't do anything other than that. You can't cancel out a p from the beginning. You could only cancel out if they're factors. Factors means you're multiplying them together. If you're not multiplying things together, you can't cancel them out. So in this case, we can cancel out a 1 plus p and a 1 plus p, giving us just 1 minus p plus p squared. That would be the final answer. Typically, what we do is we like writing answers in standard form. What standard form means is you start with the highest power and work your way down. So for example, it would just be better if you wrote p squared minus p plus 1. You wouldn't lose points on a test or anything. That's just how it is. Generally, we always write our answer like that. I wanted to show you another example where we have to factor out a negative. So the example would look like this. If we had r minus 1 over 1 minus r. Generally, what we do for these kind of problems, like I just told you, is we want to write these problems in standard form. So what we could do is just rearrange this bottom. So the top would say r minus 1, the bottom would be negative r plus 1. And if you can see, they look very similar. And they would be the same thing if what we did is we factored out a negative 1 from the bottom. The leading coefficient is negative. Watch what happens. R minus 1 on top, if we divide each of these by negative 1, you wind up with just r minus 1. It's the same exact thing as the numerator. So if you cancel out the numerator and that factor in the denominator, you wind up with 1 over negative 1, or just negative 1. If you're pretty close between factors, you factor out the negative 1 to make them exactly the same. I'll show you another example like that. What if we had p minus 2 over 4 minus p squared? Want to rearrange them, right, to get them in standard form. So what I'm going to do is I'll leave the top alone, p minus 2. The bottom I'm going to write negative p squared plus 4, and then factor out the negative 1. This would be p minus 2 over negative 1 times p squared minus 4. That looks like a special case. This is just p squared minus 2 squared. And if we factor that, we'd wind up with p minus 2 over -1 times p plus 2 times p minus 2. Then you can see we have a factor of p minus 2 over a factor of p minus 2. We just wind up with 1 over -1 times p plus 2. That would be the final answer. I want to show you one more topic before we finish out tonight. The last topic is on multiplying and dividing rational expressions. Similar to what we just did, but there's going to be a combination now. Let me show you the steps in order to do this. First step is that we want to always simplify or factor first. Next step is once you simplify or factor, the next step is to multiply straight across. What this means is if you have a fraction times another fraction, you do this times this and then this times this. We multiply numerators over, we multiply denominators. That's if you're multiplying. If you're dividing, what we do is we keep the first fraction alone. Let's say keep the first fraction the same. And then multiply by the reciprocal of the second fraction. And then just to finish this, what we do is we cancel the same factors in the numerator and the denominator. Let's take a look at a few examples. I have 4 or 5 to show you. The directions are just going to be to simplify. Let's take a look at x squared plus 2x over x squared minus 4 times x squared minus 4x plus 4 divided by x squared minus x. What we want to do first is we want to factor completely. So let's go through this. First thing we want to do is factor x squared plus 2x. We know we can take out of that. We can take out an x. This just factors to be x times x plus 2. Write that on top. All right, when we have x squared minus 4, this factors, this is a special case. This would just be x plus 3 times x minus 2. Now we have that second fraction we have to factor. It looks like that bottom would probably be the easiest. So let's try x squared minus x. What can we take out of that? We can just take out 1x from this. And we're just left with x minus 1. And then we also have to factor that top x squared minus 4x plus 4. That's going to factor as a trinomial. We're just looking for numbers that multiply before add up to negative 4. Yeah, negative 2 and negative 2 would do it. So this would factor x squared minus 2x minus 2x plus 4. Cut it down the middle. Get a negative 2. And this would be x minus 2 times x minus 2. So completely factored now. You have to do that for all of these problems. Okay, so when we multiply, on top we just get x times x plus 2, x minus 2, x minus 2. On the bottom, if we multiply multiply it straight across, we get x times x minus 1 times x plus 2 times x minus 2. Kind of the fun part, once you're all factored, you can start cutting off the factors that are the same. So I see a factor of x on top and on the bottom. I see a factor of x plus 2 on top and bottom, x minus 2 on top and bottom. And after all of this is said and done, we're left with x minus 2 on top over x minus 1. Going. How about an example like this? What if we had m squared minus 16 over m plus 3 times 1 over m plus 4? So let's go ahead and factor this. We're going to have to factor everything, and then we'll figure out what cancels out. So let's start with the m squared minus 16. This is the same thing as just m to the second minus 4 to the second, which would factor to be m plus 4 times m minus 4. I'll just go ahead and write that over here. Looks like the m plus 2 is already factored as much as it could go. The m plus 4 is factored as much as it could go. Just to finish this problem, now that it's completely factored, we'll multiply straight across. This will be m plus 4 times m minus 4 divided by m plus 2 times m plus 4. So we could cancel out. What do you see that's the same? These, right? Yeah, so we're just left with m minus 4 over m plus 2. I have a couple more problems to go over. What about we had 5x plus 2 over 6x. We're dividing, so that's different. Before we were just multiplying, but now we're dividing by 15x plus 6 divided by 5. Want to do, just like we said before, is factor completely. So 5x plus 2, there's nothing to factor there. 6x, nothing to factor. 15x plus 6, nothing to factor. 5x squared, nothing to factor. What we want to do is keep this the same and then multiply by what's called the reciprocal. What reciprocal means is that you switch the top and bottom. This is just going to turn into 5x plus 2 times Oh, you know what? You can. I'm sorry, I didn't see that. I want to do that first. Thank you. When we go to factor this, absolutely. I'm sorry I missed that. Plus 2 over 6x. And we could absolutely factor out a 3 from the top right here. And if we did that, we get 5x plus 2. Now that it's completely factored, what we want to do is keep this first fraction the same, but then flip that second fraction. So what this turns into is 5x plus 2 over 6x times the reciprocal, which would be 5x squared over 3 times 5x plus 2. What we did is we flip that second fraction, top and bottom. That's what reciprocal means. Let's see what we're looking at. It's just going to be 5x squared times 5x plus 2 over 6x times 3 times 5x plus 2. You do have to just keep everything organized so you don't get yourself confused, but if we do that, we can easily see that we can factor out a 5x plus 2, right? Let's factor that from the top and bottom, giving us just 5x squared over 18x. Something else we can do though? Take out an x from the top. And an x from the bottom. It's just 5x over 18. Sure, how put that would. I would have changed eventually. I should have caught it at that step. So thank you for doing that. So just a couple more problems, and then that'll be it tonight. What about if we had this one? It was q squared plus 2q divided by 5 plus q divided by 4 minus q squared divided by 3q minus 6. Remember, the first step is always to factor completely. We want to try to get it in standard form, maybe take out a negative. So let's just get everything sorted out here. First thing is q squared plus 2q. Can we take anything out of that? This will just be 2 times q plus 2. Any suggestions with the 5 plus 2? Let's just get it in standard form. So we'll just write this q plus 5. You always want to put the highest power of the variable and then work its way down until you get the number. All right, what about the 3q minus 6? Factor out of that. Left with q minus 2. Right? So Laquin is taking that upper right, minus 2 squared. The problem with this is that it's in a little bit of a screwy order, right? So let's just rearrange it. Let's write negative q squared plus 4, and then take out the negative 1. Now you can factor it. Now this is a perfect case. And this would just be q squared minus 2 squared, which we have been talking about how to factor that for a while now. So just be negative 1 times q plus 2 times q minus 2. Once we factor completely, now what we want to do is multiply by the reciprocal and then cancel out our common factors. So what this turns into, now that it's factored completely, is I'm going to write 2 times q plus 2 over 2 plus 5 times the reciprocal, which would be q minus 2 on top. And then the bottom would be negative 1 times q plus 2 times q minus 2. Where did I put that? The 3q, yeah, this would be 3q. I don't know why I left that out. Thank you. Just go straight across. This would be 3 times q plus 2 minus 2. The bottom would be negative 1 times plus 5 times q plus 2 minus 2. So it's completely factored. We multiply by the reciprocal, and now we cancel out common factors. So there's a lot to cancel here. 2 plus 2 cancels with 2 plus 2. 2 minus 2 cancels with 2 minus 2. And you're just left with 3q on top over negative 1 times q plus 5. Last problem for tonight looks like this. What if we had x squared plus x divided by x squared minus 2x minus 3 divided by x squared plus 2x plus 1 divided by x squared minus 7x plus 12. You know how to factor, feel free to do it on your own. You don't have to wait for me. What we're going to do is factor completely, then multiply by the reciprocal, then cancel out common terms. Just make sure that you factor carefully. So x squared plus x, take x out of that, so that would just be x plus 1. The x squared minus 2x minus 3. Looking for numbers that multiply to be negative 3, add up to be negative 2. So negative 3 and 1 would work. We could just write this x squared minus 3x plus 1x minus 3. Taking an x out, 1 out. We get x minus 3 times x plus 1. We'll go by it. Remember, we want to factor completely before we start multiplying by the reciprocal. Now we're going to factor x squared plus 2x plus 1. Numbers that multiply to be 1 add up to be 2, or 1 and 1. Write x squared plus 1x plus 1x plus 1. Down the middle, we got an x. 1. And we get x plus 1 times x plus 1. That was factored in. And then we have the very last group. The x squared minus 7x plus 12. We're looking for numbers that multiply to be 12 and add up to be negative 7. Negative 3 and negative 4 would do that. We factor with x squared minus 3x minus 4x plus 12. Cutting it down the middle, we have a negative 4. Factor the x minus 3 times x minus 4. It's completely factored now. Once it's completely factored, we could just keep that first fraction the same. Over x minus 3 times x plus 1. We're going to multiply by the reciprocal of that second fraction. The x minus 3 times x minus 4 over x plus 1 times x plus 1. Write out all the factors, and then we can start slashing them away. It does look like we get an x plus 1 that cancels. Looks like we get an x minus 3 that cancels. The final answer would just be x times x minus 4 over x plus 1 times x plus 1. That's a totally acceptable answer. Nothing wrong with that. If you want, you could even write it a little bit fancier. X times x minus 4 over x plus 1 times itself, or just squared. Either one of these are fine.